All right, good morning, my beautiful followers, and welcome to today's class. In my last video, we demonstrated how you can achieve an automatic phase selector using relays. In that video, we made use of this type of relay, which is rated only 10 amps. And then, of course, knowing my kind of followers, they are very technical and intelligent guys. They came up with a new question. That question was, how do we power heavier loads making use of this relay? This is just 10 amps. How do we do that? There are two methods. Number one is to go for bigger relays. We have these two types of relays here. This one can handle up to 40 amps at 220 volts, while this one here can handle up to 60 amps at the same 240 volts. All right, so it's either you make use of these relays or you make use of these big guys, the contactors. But in this video, I don't want to make use of this relay because it is the same thing as this one. The only difference is that these ones have a pin and then of course a base where you plug it in. These ones have contacts here where you can actually fasten your power cables. Likewise here, of course, these are the coil terminals for this one. This one also has its own coil terminal where you can actually solder the wire for the coil here. I don't want to make use of it because it's just the same thing as having common, normally open, normally closed, just like the smaller relay. But I don't want to make use of it. So with your knowledge on this one, you should be able to do this one. But in this video, I will be making use of contactors. All right. These three contactors are all rated 60 amps each. What that means is that each of these terminal is rated 60 amps. This one is 60, this one is 60. Likewise, all these power contacts, each of them is rated 60 amps. And one thing I need you to know about automatic phase selector is this. We have only 3 phases. And the job of automatic phase selector is to select one phase out of the 3 phases that we have. It selects only one. What that means is that we are operating a single phase machine because it's going to be only one phase that is going to come out from this by the time we are done. That is the job of a phase selector. So in that case, we may decide to make use of only one contact here to power our loads. If it is around 60 amps, we may also decide to make use of 2, or we can make use of the 3 by looping them together. That is possible. We could do that to achieve what we want to achieve. But for now, let us go into the control of this particular system. Now, what do we want to achieve? We're going to have the 3 phases connected to these 3. And we don't want these 3 contactors to energize at the same time. We want only one to be energized. It's only one that should give us the phase we want to use. In that case, the logic I want to use here now is this. When this one is energized, these 2 should not be energized. All right. When this one is energized, these 2 should not be energized. And when this one is energized, this one should not be energized. So this one can only be energized when this one fails. This one can only be energized when this one fails. And this one fails. So if this one doesn't fail, this one cannot be energized. And if this one doesn't fail, this one cannot be energized and this one cannot be energized. So this is exactly what we want to achieve. And to achieve that, first of all, let us connect power to the whole contactors. And remember, our power terminals remain A1 and A2. We have A1 and A2 here, and then we also have A2 that came all the way from the other A2 through a straight conductor to here. So we have A2 here, A2 here, and another A2 on this one. All right? So, but we're going to be making use of A1 here, and then because this side is closer to our neutral block, we're going to be making use of this side as our neutral. So for clarity's sake, I'm going to move our neutral block closer. Let me move it closer so that it will be visible in this video. Just one moment. I'm going to put our neutral block somewhere here, temporarily, for the sake of this video. So I believe this is enough. You can see our neutral block here. So we're going to take our neutral from here to this one. So to do that, we get our cable. And then of course, our handy tool. Strip this one. Open here, insert this one, and tighten it. Make sure you lock it up properly. And then bring it here as well. Strip this one. And then strip this one also. Make sure they are properly dressed. Slack this guy out. And then insert this cable here. And then insert this one also. And then you lock it up. So the next thing is, we'll bring it here also. Strip this cable this way. Strip this one this way also. Make sure it is clean enough. And then you slack this one out. When you slack it out, you insert here. And then you insert this one also. When that is done, you lock them up. So after that, you take this one straight to the neutral block. Slack this one out a bit. And insert this. And then you lock it up. So we've completed the circuit for our neutral, all right? So the next thing to do is to wire another cable to the coils of our contactor. Let us start with this one. So I'm going to strip this one. I'm going to connect it to our A1. Don't do the mistake of connecting this to A2 because you already connected your neutral to A2. So put it this way, lock it up, and then we can decide to take this all the way to the red phase. Okay? So now we'll get the next wire, connect it to A1 of this contactor. Lock it up. Clean this one up. Strip it. And then connect it to the yellow phase. Alright. The yellow phase is intact. And then get the other cable. Connect it to the A1 of the third contactor. And set it. Lock it up. And then insert this one on the blue phase. When that is done, you lock it up. So, with what we have right now, if we bring in our power supply, what we have here is 230 volts. If you close this breaker, this one will close. If you close this one, this one will close. And if you close this one will close. We don't want these three. We don't want the three of them to be closed at the same time. This is not what we want. We want only one to be closed at the same time, because if we do it this way, we have red, yellow, blue. Three of them are going to jam, and that is going to be disastrous. This is not what we want to achieve. What we want to achieve, we want a situation where when this one is energized, this one should be disconnected and this one should be disconnected. And the way to achieve it, the only way to achieve it is to use the normally closed of our auxiliary of this particular one. So from my explanation, this one requires us to use two auxiliary contacts from here. But unfortunately, this one is equipped with only one normally closed contact, which is this one here. Likewise, this one has this one here normally closed, and this one has this one here as normally closed. So what are we going to do about it? We're going to make use of this auxiliary switch. So how do we insert it? We position this here and we slide it in until it locks. And this is what we have. And then you confirm it by pushing this down. All of them should be going down. If you look at here, you see that yellow stuff? They're all going down. So if you put this on, we see that this is going to go down. Don't worry about this vibration. This humming you're hearing here is not a very good contactor. It's as old as myself. So you expect anything from it. This is for training purpose. Okay? So what do we do now? Instead of taking this coil, the power from yellow phase, instead of taking it direct to this yellow contactor, we're going to take this cable through the normally closed of this one to this place. All right? So to achieve that, this is the wire. We're now going to take this wire, which is coming to the A1 of this one, we'll connect it to the normally closed of the one of the normally closed of this auxiliary block. Now we have normally open, normally open, normally closed, normally closed. So we have two normally closed contacts on this auxiliary block. That is why we're going to use it. So first thing to do is that we disconnect this completely by cutting off this wire. And then we strip it. And then we come here and then we slack this guy out. Slack it out and then we insert this one here. When you insert it, you lock it. This particular one is not long enough. It will not get here, so I'm going to remove it. I'll remove this wire, and then maybe I'll get a longer one. So I'm going to use this one, I'll put it back, replace it with this one in A1. Insert and lock. Having locked it, this one should pass here, and then it should come to this place on the normally closed. So what we do is we strip this one, insert here, slack it out, insert the wire and lock it. All right? So, having done that, let us put on this one. You see, it's still closed. Why it's closed is because this one is not closed. If this one closes, it's going to disconnect this one here, and this one will disengage. So let us put it on. You see, this one has closed, and it has opened this one. This is the same thing we want to achieve for this one. So let us shut down the power, and then route this one through this one as well. Okay, so we'll now get this wire, which is the one coming directly from the blue phase to this one. We'll get it disconnected. Instead of cutting this wire, let me just disconnect it from A1. So I take it off from A1, which is this one, and then I insert it on the second normally closed. Set it here and lock it up. And confirm it is locked. We'll now take another wire, which is now going to come from the A1 of this contactor. And then we're going to bring it to this normally closed on this side. Slack this guy out, insert this wire, and lock it. All right, So what we have now is that this one can close. This one also can close. All right? Let us put it off. We'll close this one. We'll try to close this one. It cannot close anymore. We'll try to close this one. It cannot close anymore. Two of them can only close when we disengage this one by doing this. All right? So, you see this one, they have closed. Okay? Sorry, you are not seeing my power source. We have my breaker somewhere. I need to adjust this. I'm just trying to make this thing to be as close to what I'm doing as possible so that we can all understand. I think this is a lot better. All right, so let us disengage. If this one is on, this one cannot close. It can't. And this one cannot close. It can't. Two of them can only close when we disengage this one. Like that. You see? They have closed. But we don't want these two to close at the same time. We want only one contactor to be on all the time. So for us to achieve that, instead of taking this wire direct to the coil of this one, we're now going to take it to pass through the normally closed of this one. And that is going to save us a lot of stress. So to do that, of course, as usual, I cut a lot of wire. Cut wire for a living. So we'll do this, and then we take it to the normally closed of this one. This is the normally closed, the one below. We'll slide this out, insert this wire, and lock it up. And lock it up. Sorry, this one didn't go in properly. Let's lock this. Insert it and lock it. This is locked. And then this wire, which is the one that is connected to the A1 of this one, I'm going to strip it like this, and then I'm going to insert it to this normally closed of this one. Okay. After that, we'll lock it up. That is locked. So what else do we do now? Let us test again. Let us energize this one. It has energized. Let us energize this one. It cannot energize because this one has opened the circuit, the coil circuit of this one. This one can only make when we de-energize this one. So we'll de-energize this one has made. So now if we energize this one will disengage. So what that means is that if this one is on, we cannot engage this one, and we cannot engage this one. And if this one goes off, only this one will be engaged. We cannot engage this one. You see, this one is engaged and this one has disengaged. So the only time this one can engage is when this one is disengaged and this one is disengaged. So let us disengage this one. And you see this one has engaged. All right. So if we engage this one again, it will disengage this one and only this one will be on. So if you look at this now, there are a few other things we can add to this. Maybe a delay circuit or a timer. We can include a timer, but that is going to be in our next video. If you like this video, please let me know in the comment section. If you also have a question, please let me know in the comment section or send me a private message. Share this with your friends and continue to follow me for more tips on power. Thank you very much.
Please like and subscribe. Thank you.